Hello, ladies and gentlemen, and welcome to your first video as geometry students. We're going to talk about the segment skills and what that all includes. So you're going to need that foldable, a pen or a pencil, and maybe a calculator. So for starters, let's talk a little bit about the theorems or the basic segment properties we're going to have. The first one we should talk about is the smaller segments can be added together to create larger ones. So what that means is if I have two different segments, just like this, if this one was 4, and I have another little segment that is like this, and we'll say it's 7. I take those two segments and I add them together on one line. Oops, this one's 4, sorry, I meant that to be a dot. And this one's 7. That's saying that I now know that this entire segment right here is 11 because I took 4, I took the first segment, I added it to the second segment to get 11. 4 plus 7 equals 11. The second theorem we're going to talk about is the difference. I guess it's not technically a theorem, but just understanding the difference from notation when we're describing a segment versus its length. So if I'm talking about a segment AB, if you remember correctly, the segment notation means just that bar on top of AB. So this would be a segment. Now, if I see AB with no bar, that's going to mean the length of that segment. Still a segment because we're talking about length, start and stop point, but without the bar on top, we know we're talking about the length. We're finding the distance of that. The next thing we should talk about is noticing slash marks on a segment. So if I have a segment, I'm sorry, my lines are not very straight. Okay, here's my segment. If I have a slash mark here and a slash mark here, this theorem tells me that they are congruent. Now remember, congruent is just another word for equal. So they are equal to each other. So if this was a segment PQR, this would mean that PQ, segment PQ, is congruent to segment QR. But this also means that PQ equals QR. Now, what's the difference in these? Here, this first notation, I'm talking about the segments. Now, two segments can be similar. They can be congruent, but they're obviously labeled differently because they're different segments. So that's why we say congruent. But the distance or the length of each segment can be equal. That's what it means to be congruent. They equal each other. That's the difference in these two notations. Lastly, a midpoint. Thinking about that word midpoint. We're going to assume it's in the middle. Okay, so midpoint means middle. So thinking of if I draw a segment like this, and I say that D is the midpoint of EF. So if this D right here is right in the middle, okay, understanding that that just means that D bisects the segment EF. What does it mean to bisect? Bi means two. If you think of intersect, split in half. Okay, so this D is going to split EF into two segments. But since it's right in the middle, that means the distance from E to D is the same as the distance from D to F. So again, we could draw those slash marks in here. They're going to be congruent. They're going to be equal. Okay, so moving forward, understanding that midpoint means that I'm talking about a point that's in the middle of 2 points, meaning that the segments it creates, so DF and ED, I want to write that over here real fast, ED is congruent to DF. That's what it means to be in the middle. It cut that segment right in half, so this part of the segment is equal to this part of the segment. So getting down to it, our first example, the points R, S, and T are collinear. Well, what does it mean to be collinear? We just did that vocab. If you don't remember, look back in your notes. Okay. Collinear means 3 points on the same line. So this is just a segment or a line, however you want to say it. Okay. And we have points R S, and T. Now, do we always have to draw a diagram? Not necessarily, but I like to draw a diagram so I can see it and I can label it and I know exactly what's happening. So we know that RS is 2x minus 4. So I'm going to label RS 2x minus 4. Just to take a step back quick, why did I put S in the middle? Why does S have to go between R and T? Right here, it's labeled in the middle of R and T, and then they're collinear. That means they're all on the same line. It's happening in sequential order. So that's why S goes in the middle. Now the next thing we know is ST is 3x plus 7. I also know that the whole segment RT is 43. Okay, so I know the whole segment is 43, and I know that 2x minus 4 is RS, and ST is 3x plus 7. So thinking back to that very first bullet that said smaller segments can be added together to create larger ones. Okay, so I know that RS plus ST should equal the whole segment. I know that if I take this smaller segment and this smaller segment here, this smaller segment here, and I add them together, it should equal the whole segment. So now that I wrote out this equation right here, all I have to do is plug in for what I know. I know RS, I'm going to take this, go over here. I know that RS is 2x minus 4. I know from right here that RS is 2x minus 4. I also know that ST is 3x plus 7. So I'm going to plug that in, 3x plus 7. Now what is RT? RT is the whole thing, and we were told that RT is 43. So this whole thing equals 43. And now this just becomes an algebraic problem. We're going to combine like terms on the one side. So I get 5x. Okay, now if I take negative 4 and I add it to 7, I'm going to get a positive 3. And this equals still 43. Now that my like terms are combined, I'm going to take what's on the left-hand side and I'm going to solve for x, getting x alone. So 5x equals 40. X equals 8. Okay, but it didn't want me to just find x. It also wants me to find RS and ST. So how am I going to do that? How do I figure out what RS and ST are? Can I just look at the picture and be like, well, that's 32 and that one looks about 14? No, that doesn't add up to 43. So I have to figure it out mathematically. RS right now is in terms of x, but we just found what x is. So we can do some mental work or some math on the side here. RS equals 2. What is x again? Well, we just found out that it was 8. Oops, minus 4. So 2 times 8 is 16 minus 4. 16 minus 4 equals 12. So now I know that RS equals 12. Now that I know that RS equals 12 and I know that RT is 43, can I figure out what this missing piece is? This is 43 and this is 12. What's ST got to be? Well, I'd take 43 minus 12 equals 31. So ST is 31, X is 8, and RS is 12. My problem is now complete. So example 2 is very similar in the way that we solve. It's still that segment addition little postulate we have. So I'm going to take the two smaller segments, DE and EF, and I'm going to add them together to get the whole segment we have here. So I'm going to take 5x minus 2 plus 3 equals 3 times the quantity x plus 3. Okay, so on the left-hand side, I'm going to combine like terms. I'm going to get 5x plus 1 equals, what do I got to do on that right-hand side? I should probably distribute. So I'm going to get 3x plus 9. Again, using your algebra, if I take it to the other side of the equal sign, I got to do the inverse operation. 2x plus 1 equals 9. Subtract 1, subtract 1. 2x equals 8. X should equal 4. But I didn't only have to find x. I have to find DE and DF. So plugging in for DE, I know what this x is. I can plug the 4 in for the x. So I'm going to take 5 times 4 minus 2. 5 times 4 is 20. 20 minus 2 equals 18. So now I know that DE is 18. Well, if this segment is 18 and we know EF is 3, in order to get the whole segment, we take the little segments and add them together. So DF, without having to plug it in, what's DF? Should be 21. Did we solve all that we were asked to solve? X, DE, and DF? Sure looks like it. Let's move on to example 3. In example 3, we're told that B is the midpoint of AC. Now, if we needed a picture, we could draw a quick picture. Not all of us might need that picture, but I'm going to draw it for us quick. So AC is my segment, and it tells us that B is the midpoint. So thinking back to that bullet 4 that we wrote down, midpoint means middle. And remember what we said about the middle? That means that both sides of my segment should be the same. And how do we mark that? We should mark that with a slash. So I know that those two are congruent. So AB has to equal BC. Okay, so AB equals BC. Now we know what AB is and we know what BC is. So instead of writing AB and BC, why don't we just write the equations that stand for them? 2x plus 12, which is AB, that's this one right here, equals BC, which is 5x plus 10. Again, once we just get this set up and we understand the postulates, it just becomes that algebraic problem. So I'm going to subtract the 2x, subtract the 2x, 12 equals 3x plus 10, subtract the 10, subtract the 10, 2 equals 3x. It's not going to divide out nicely, but it will give us a fraction. So divide both sides by 3. X is going to equal 2/3. Was I supposed to find x? Yep, but what else am I supposed to find? I also need to find AC, which is the whole segment. Am I given the whole segment? Absolutely not. So, but I do know that half the segment is AB. So if I know what half the segment is, in order to find the whole, I can just multiply by 2. So let's figure out what AB is and then double it. So if I have to figure out what AB is, I know now what x is. So let's plug in x for AB. 2 times 2/3 plus 12. Okay, so now I'm multiplying fractions. How do we multiply fractions? Multiply straight across. So I'm going to get 4/3 plus 12. Okay, but now I'm adding fractions. But 12 isn't a fraction, so I'm going to put 12/1. How do I add fractions? Can I just add straight across? Nope. I hope we're all saying nope. Okay, in order to add fractions, you have to have a common denominator. So how do I make 1 a 3? Well, I would multiply by 3. What I do to the bottom, I better do to the top. So this is going to be 4/3 plus 12 times 3 is 36. 1 times 3 is 3. Now that they have that same denominator, I can add the top to get 40/3. So this is good work, but this was just what AB is. So now AB is only half. So how do I figure out the whole? I will double it. Again, since I double it, 2 is not a fraction. So in order to make it a fraction, I'll put it over 1. Now that I'm multiplying, again, we know that we should multiply straight across. 40 times 2 is 80. 3 times 1 is 3. So my final answer for AC is 80/3.
All right, so in example 4 here, let's just see what we have. Notice that we have markings on our segment. These two markings, when they share at one hash like that, again, hopefully you remember that that means that they are going to be congruent, okay? So if they're congruent, that's just another fancy word for equals. So I can determine, okay, well, AB has to be equal to BC. So when I write this out, then I can fill in what I know. So if I know AB is going to be 2x squared plus 3, I'm going to plug that in for AB, and BC is 101. Okay, so when I plug in what I know, it looks like it just becomes a math equation that I'm going to solve. So I'm going to get 2x squared. In order to get rid of that 3, I'm going to subtract it from both sides. So the 2x squared equals 98. Then I'm going to divide both sides by 2 to get x squared equals 49. And now I have to get rid of this power of 2. And if you think back to Algebra 1, hopefully you remember what undoes the power of 2. Squaring something, hopefully you remember that the square root is what gets rid of that power of 2. So when you take the square root of 49, we get x equals 7. So again, if you wanted to, you could plug that x in to see if it's going to work, to save us a little time today. I'm just going to let you know that it does end up working. So 7 would be your answer for example 4.
For example 5, the setup should be very similar to what we've been doing in the video. So what I'm going to do is I'm going to have you work on this in class. The only thing that's going to be a little different is how we go about solving. So we'll use this as a challenge problem. So you challenge your neighbor, see who can get this right. See if someone knows how to solve this. Thank you for taking good notes. Kessler out.